Hey, what is up guys? Welcome back to another video. This is section 1.2, Piecewise functions. So we've done a review of our linear functions, we covered absolute value functions, and now piecewise functions. So what is a piecewise function? A piecewise function is a combination of two or more functions. So you can see to the right side of the screen that we have two functions on one graph. And so, but the thing is, it's kind of broken up right here, right? It doesn't look connected. So piecewise functions, that's what they're going to look like. So let's try to identify what these functions are. So right here, this function right here, that's just like a negative sloped linear function. So that looks like it's going to be f of x is equal to negative x, right? But then this function over here is just a constant function right there. So that looks like f of x is equal to 2. So those are our two functions, but the question is, how do we write it? Because the thing is, f of x equals negative x, the blue function, it only exists up until 0. And then after that, f of x is equal to 2. And before 0, f of x equal to 2 doesn't exist. So we have to write that. So how we write that is this. We have to write the x values for which this function belongs or exists. So for a blue function, it exists for all negative numbers. So we say f of x is equal to x if x is less than 0. Okay? And then we say f of x is equal to 2 if x is greater than 0. Alright? It's pretty straightforward, except there's one issue, and that is what's going on at x equals 0 right here. At x equals 0, because we have two possible answers, do we not? So if I were to do a table for x and f of x, if I plugged in 0 in one of these equations, I would get that f of x equals 0. If I plugged it into another equation, I would get at x equals 0, f of x equals 2. So right here, f of x is equal to 0 when x is 0, and right there, f of x is equal to 2 when x is 0. So this is a problem, because for the definition of a function, if you go back and look at it in our review, the definition says that for every input value, there is only one output. So right here, here's our input value. We have two different outputs for 0, and we can't have that for a function. And so we have to tidy up over here what our function looks like. And so you might have noticed that here we have a closed circle and here we have an open circle. So that indicates where our output lies and where it belongs at this x value. So where we have the break right here, we have to signify where that value belongs. So we're going to write right here that f of x is equal to negative x if x is less than or equal to 0. So that lets us know that this right here, that this is where that one output lies, right here. So when we plug 0 into our equation, we're going to get 0, not 2, because we can only have one output for when x is 0 right here. So what does it mean when you have a greater than or less than an equal to sign? Well, this means that the value, so that output value, is included in that portion of the piecewise function. And we show a closed circle. And what does it mean when it's just less than or greater than? Well, this means that the value is not included in that portion of the piecewise function. And we show an open circle. Alright, so now how do we evaluate for a piecewise function? So, we see here we're going to try and evaluate for x equals 0. But we have two different functions, so how do we know which function to plug it into? So that is dependent on where your x values exist, right? And so right here we say that for x is less than or equal to 0. Well, 0 is less than or equal to 0, so that's the function right here that we're going to plug the x value into. So we're going to say f of 0 is equal to 0 minus 2. So f of 0 is equal to negative 2. Now, let's go to this one right here. For f of 4, now where does 4 exist? 4 is a positive number. This function right here, this piece of the function is for negative numbers, because x is less than or equal to 0. But this piece of the function is for positive numbers, and we have a positive number. So we're going to plug 4 into that part of the equation of the function. So 2 times 4 plus 1. So this is equal to 8 plus 1, which is equal to 9. So there you go. That's how you evaluate a piecewise function. You just have to determine which the x value that you're given, which piece of your function does it belong to. Okay, now we're going to talk about domain and range. So the domain and range, we probably touched on it in the last two videos a little bit slightly. So the domain is our x values. And so where in our function are the x values? So looking at the x-axis right here and where our function touches, you can see here that it's going to go from negative infinity all the way over to here, but then it stops. But it picks up right here and continues over this way right here. So and in terms of in the case of these two spots, it stops here but picks up up there. So for our x values, we hit every possible x value. And so our domain is from negative infinity to positive infinity. Now let's talk about the range. So the range is our y values. Now you can see here that when we look at our y-axis right here, that it will exist all the way up to this point, but then we have this entire section where the function doesn't exist, but then picks up right there. And so this right here, this is at 2, and this is at 1, right? And so we will be going from negative infinity all the way up to 2. And then, I'm going to do comma, we pick up at 1 and go to infinity. Now my question is whether or not we show a bracket or parenthesis right here. So where that entirely depends on where our closed and open circle is. So since it's closed, we're going to draw a bracket. And then for the 1, since it's open, we're going to draw a parenthesis. So this tells us right here that our y value is included right here and not right here. So even though it looks like right here that there's a 1 right there, that it's at 1, it actually never is at 1. This function right here, this piece of the function, will continually go to 1, but will never actually reach 1 right there. Never. It will infinitely go into 1, but never actually hit 1. So there you go. We have our domain and our range. So is 2 included in the set of solutions? So 2 will be included right here. So yes, it is included in our set of solutions. So if we plug x equals 0 into this piecewise function, we will get 2, but we will not get 1 right here. So 1 is not included. So yes here, but no here. When x is 0, our y value will be 2. Alright guys, so that should pretty much cover it. Pretty short video. This is pretty easy stuff, and more you guys can handle this fairly easy, I believe. But if you have any questions, please come to class prepared, or shoot me an email, or go back and watch this video and try and clear things up. But if not, I will see you in class. Thanks guys.